Well, Chris, the only announcement I have is I finally got your schedule up and I put it up on the Journal Club section of the members section on our website. So I think I have it through April. So it's underneath the current Journal Club. Underneath that, there'll be future Journal Club, and I should have all of the dates and papers. What I haven't done yet is Chris and I have to run around and find copies of these papers and post them up there. So I haven't done that yet going forward, but at least you can see what the papers are, and some of them you can get to.
And next month is Brian's.
Yeah, Brian did send me a copy of that. I need to I have a bunch of scanned PDFs I need to combine into one. So, but I do have the papers.
Well, Fabio Silva was hoping to join us tonight for the second half of our discussion. He didn't want to come in the beginning so that he would influence any discussion on his paper, but that's fallen through at the last minute.
Okay. Well, Rick and I were wondering, is he in England?
Right now he teaches at Bournemouth. He's from Portugal, but he was teaching at University of Wales with Kim Melville, Nick Campion, but he has since moved on to Bournemouth.
Okay. So I was wondering, it'd be quite late for him.
Yeah, pretty late. Yep. And he's also a co-editor and founder of the Journal for Skyscape Archaeology.
No, I've read his work for a long time. I was kind of anxious to meet him. So if it
Yeah,
doesn't happen tonight, we should have another opportunity. So
Oh yeah, he's definitely willing to come back.
that would be good.
In fact, we have another one of his papers scheduled, I think.
Oh, we do?
I think so.
Oh,
It's your schedule.
good. I've read a lot of his work, yeah. But a lot of it he's made me work as I've studied under it. Or a lot of it he made me read. But yeah, I was hoping he would come tonight because it is more of a difficult paper than some of the other stuff that we've read through. I'm not strong in statistics at all, really. So I'm hoping everybody else kind of chimes in. I have some points that I've come up with, and we can talk about. But I'd like to start off at least by opening it up to I have some points too that I can share later, but I'd like to open it up and just see what everybody else thought. If everybody read the papers, I hope.
Yeah.
Afraid I haven't had time to read that paper.
Yeah, it's a heavy lift for sure.
I'm so sorry. Could I ask a quick question before we start everything? So because I'm kind of a new member, I would like to ask how the organization got started. Just a little brief explanation. Thank you.
I'll put that to Chris or Rick or Ray.
Maybe Ray, you're probably one of the older members. You're muted. You're muted, Ray.
Nope, we still can't hear you.
I said,
oh, there we go.
I'm certainly one of the older members. Well, it got started by Greg Munson and several other people. I think Kim was involved, Kim Melville originally. And it has, the idea was to focus on the Southwest because there's so much work being done, so much research being done in the Southwest for obvious reasons. There are cultures that we're looking at from history that are also have descendants here and have knowledge that is very useful in interpreting what we're looking at in structures, as long as you're fairly careful not to over interpret. and so forth. So it's not a very it's not a very detailed history, frankly, but there is a we're doing a paper, I hope, Greg and I, in this fall at the conference in Argentina, in La Plata, Argentina, outside of Buenos Aires. And we'll have some more information in that paper about the beginnings of the organization and so forth. So since I wasn't there at the beginning, I came in later, maybe even after Chris, and certainly Rick. So
I never,
I may not be the best person to talk about that.
I never thought I'd be considered sort of one of the old elders, but and before my time, I don't know if you're familiar with the Oxford conferences. There was Oxford 7, if I recall right, was held in Flagstaff, Arizona. And several of the members that are sort of here helped to organize that conference. It's an international archaeoastronomy conference. And this organization was really a spin-off of that. A bunch of interested people got together and felt that the Southwest was a place where the cultures are here. This is a great place to be a society such as ours. And so it really sparked out of that. And our newest charter and name change and everything happened, I'm going to guess about 7 years ago, but there was some organization before that. And so our newest iteration is now about 7 years old. And we now have about 75 members. And that's kind of how it started.
And is the purpose to interpret scholarship or to add to the scholarship?
Both.
Both.
Both, yeah.
Absolutely.
Thank you very much for that diversion. I appreciate it.
That's a perfect segue, because part of what we've been working on and part of what the Journal Club's kind of theme was from Chris is kind of guiding that loose scholarship and trying to put some formality to it to add to the scholarship. So
I've tried to pair papers, generally speaking, with a bent towards methodology and a scientific method. I tried to pick a seminal paper from the field and pair it with something that was written from within the society. It's kind of broken from that this month, as the first paper is from Fabio Silva, and his examples are from ancient Egypt and the Scottish recumbent stone circles, which are certainly not the American Southwest. And the second, basically sticking to the theme of statistical analysis to show that our findings are statistically significant and not just the product of randomness, or that they can be shown to be outside of what's could be happening randomly. There's nothing really that's been published to my knowledge within the society dealing with that topic, so we kind of pulled it back for the second paper of something seminal yet related, even though Dr. McCluskey is not in the society. Most of his work is in the American Southwest.
So I don't know, Chris, do you want to give a quick synopsis of Sylvia's paper, just so we make sure we're all on the same page, because there was a lot of, like you said, it was statistically heavy. And I don't think, we don't need to get into statistics of how to do it. It's more of the application, I think.
Sure. So one of his first points was, and I agree, I don't want to get it too math heavy, but I did want to just point out, Rick, if I could share my screen.
Oh, I'm sorry. I got.
just the very first equation that Fabio talks about when he let's see.
We can see it.
The very first equation he talks about in the paper is, if you're going to be doing any kind of field work, it's probably something that you should be familiar with. This isn't exactly how he has it. His paper, his equation. He talks about the sine of the declination equals the sine of the latitude times the sine of the altitude plus the cosine of the latitude times the cosine of the altitude times the cosine of the azimuth. And this is something that's going to be pretty important if you're actually working out in the field to come up with astronomical declinations, because that's what that's the point of the field work is to find your declination compared to ephemerides that might predict celestial phenomena along the horizon, and then if you can get photographic confirmation. But of course, like Fabio talks about, the coordinate system of astronomical declination is different than the one you would use out in the field, because you can't really directly measure it. So we use a horizon coordinate system where we go out with either our theodolites or total stations or our compasses and get our magnetic bearings or our, eventually our polar azimuths and our horizon altitudes, because without the horizon altitude, you can see that everything kind of falls apart. If you don't have your altitude measurements, you're not going to correct declination. Oops, I probably didn't want to do that, but this was basically Fabio's methodology that he talked about. The first one was decide on a probability distribution to model the orientation measurements. And he talked about two probabilities using, let me just make sure I get the names right.
It's like a normal distribution and then
Right.
continue.
Yep, the normal distribution and the, what did you call the second one?
I think it was like a continuous or a uniform, I think you called it.
Yeah, uniform.
Uniform, yeah.
Correct. Okay. And the great quote that I pulled out of it, well, I thought this one, that the azimuthal probability distribution represents one's a priori assumptions about the measurements relationship to potential alignments, and this choice affects the shape of the aggregated distribution, whether it be the SPD as defined here or the curvagram. And that's just a bunch of tech talk to say that whichever model you choose, if you go with the normalized, you basically run the risk of telling the data what it should be looking at instead of the data telling you where you should be looking, which I thought was a really good takeaway. And then the coordinate transformation that we just talked about in this formula, where he's talking about the altitude in his model, his computational model, he's using an entire horizon profile, and the one he uses is called Hey What's That? I don't know if you guys ever have used this website. This is our horizon model that I generated from Shaw Butte in just north of Arizona at a Hohokam site. And as long as you take good latitude and longitude measurements, you can put it in and generate a whole horizon profile, which works out well for me because I'm usually down in Central America doing my readings in the jungle, and I don't really ever have a horizon. And then,
I'm sorry, can you go back to that for a second?
sure, I can.
So I don't see an axis that tells what the altitude is, but I'm assuming then you just
Okay, yeah,
basically press on those little red things. And
Yeah, I just, you can click on the red things and it gives you all kinds of great data.
Okay.
I cut it off here. This is a 0. This is a 0 degree
Okay.
mark, and this is 1 degree.
Okay.
But it does other kind of nice things that you can actually take 2 points on.
And how confident are you about it's just general accuracy?
It's pretty accurate, I believe, but it's not. The definition just isn't there.
Yeah. I see what you're saying.
Andy Monroe and I took some What's Up Horizons from Chaco Canyon, and we used some of his field work to test out the accuracy of this, and some subtle horizon features that they did find marked solstitial sunrises were not even detectable in the Hey What's That app. So
I would
of course,
imagine it's more reliable at distance than it is close
yes,
up.
it's
Chaco Canyon is a very
certainly no excuse. I mean, no, it's no replacement for actually doing horizon profiles if you have the ability to do so.
There's a question in the chat, just to clarify.
Yep.
I don't know if you can see it.
www.heywhatsthat.com.
Thanks.
And then you'd want to go to the second page. It's called, let me stop sharing for a second so I can look at it myself. Or, you know what, I can just share this out. Let me just do that. And then everybody just doesn't have to. Can you see that screen?
Yes.
Yeah.
So what I did is I'm just using this. I mean, what you really want to do is give your profile a name. I mean, if you go to the website, you're gonna want to click the page, new parent panorama. And once you click this tab, the new panorama, you can give it a name and then put in your latitude and longitude. I usually get that from from my Garmin that I have out in the field. And
it might be a good exercise, and I might try this, is to actually use it and then sketch it, and then mark the points that you want to actually, because you don't have to be that good a sketch artist to only get sort of,
right.
And then very specifically point out where you're calling out the markers where you need to know an altitude. That might be a good way to do that.
Yeah, definitely. And you definitely want to put in your own latitude and longitude. I don't have anything handy, so I was just clicking on the map here, and that's certainly not how you want to do it. But if I click that guy and then I Chaco. See what this does. Doesn't take a whole lot of time to do this. So you can see there, Chaco is actually pretty flat.
Okay.
And then to answer your question earlier, Rick, If I
Okay.
click that, it gives me my 0 and my 1.
And I imagine it would also go higher if you had more information up above it.
Yeah. So if I wanted to click here, for instance, then I can actually get a profile too,
Oh yeah.
which is
Very
pretty
clever.
nice. So
I'll
so
play
it's,
with this. This will be good.
yeah, it's not, it's, of course, the application horizons is probably better. And there might be other tools out there, but for a really quick and inexpensive, cheap, it gives you pretty good detail, I think. So this is what Fabio was using when he talked about taking the transformation equation and using the full horizon profile. He was actually pulling his data from this web page.
Okay.
And I don't know, did anybody else have any comments or anything they wanted to talk about, at least on the first half of
Back to the declination. And so I'm kind of new to this, and it just never would have occurred to me to basically instantly turn your horizon over to a declination. And it makes so much sense. So I think for any of you that are out there and just kind of like deal in azimuth, that's I get it, and that's what we're naturally that's how a compass works, and that's what we normally do. But using that formula that Chris was showing us before and turning your horizon with its altitude, features immediately into declination just makes perfect sense. And I never really thought about it until that's what he did, and he was describing this thing. And I thought, well, that's it, because then you know specifically what astronomical object, star or sun or moon or anything, is going to hit that point in the horizon, because you already know its declination. So any object with that declination is going to hit that horizon at that point. And so anyway, it was kind of like a hit your head and say, duh.
Yeah, I probably
saw that. I thought, well, this is absolutely right.
Yeah, I probably glossed over that pretty quickly then.
Yeah.
Because if you're out in the field, if you're going quick and dirty, on the cheap, you'll probably have a compass and a clinometer, like Sunto makes a combo compass clinometer, where you can use that to. And then, of course, some kind of GPS. I take a handheld Garmin out with me, because you're going to need to get your azimuth and your altitude and your latitude. So you're not going to directly measure azimuth either. I mean, what you can measure with your compass is your magnetic bearing from magnetic north.
Right.
And then, of course, you would have to convert that to polar azimuth by taking account of your magnetic declination, or use some other kind of method like a theodolite and do sun sighting, and you would basically compute then your azimuth. Your horizon altitude you can directly measure from your clinometer, and your GPS you can pull right off of your Garmin or whatever. But you definitely need those three pieces of information at least to plug into your equation to get your astronomical declination. And then once you have that, of course, then you take it to an ephemeris, and you find out what at the time of occupation, what was rising on the horizon at that declination. Because if you know the declination, you know what's gonna, every coordinate system uses two different angles. In the horizon, we're using our azimuth and altitude, but we only use those so that we can convert to declination. The other one uses declination and right ascension. But all we really need is the declination for what we're doing.
That's correct. Have you ever heard, has anybody ever heard of Chinese coordinates or whatever?
No,
See that reference? I've never heard the term.
I never heard that reference either, and I read it and I thought it was something I'd never heard of before. Where is he going with this? But it's
And that's
just
why
right.
he should be. That's why he should be here tonight.
Yeah, but it's just the right ascension and declination is all he's
Yeah,
talking.
I get it. Yeah.
So Chris, a quick aside before we move on to this. One of the motivations for what he's doing in this paper, he cites as is dealing with the error. So you have the error in the horizon measurements, and then when you convert it into the equation, he cites here that the standard method is to just run that into the equation itself to get your error. And this came up in some previous papers in a previous journal club where, again,
Right.
it's getting the error out. And I just want to,
Yeah, that
error
was
propagation is something near and dear to me. And if you have the equation, and like this is a nonlinear equation, you can, there's a method, quadratures error propagation. So if you have the equation, you can see, because when you take your horizon measurements, there is an error, and it would be appropriate to also do that error propagation through this equation so that you know what your declination error is.
Yeah, I agree.
Yeah, the paper you're talking about is the very first one we had at the first journal club by Andy Monroe and Kim Malville on the field methods of Chaco Canyon, where Andy was measuring the wall of Pueblo Bonito at 1 meter intervals so that he would get enough data points to find a standard deviation.
Right. And it doesn't take away from the paper here. I mean, he can get at, the significance of the error, but you can know what the error is from your at least from measurement error.
Mm-hmm.
So.
Does this Sky software that's available to us nullify the need for these, or is there a great value in being able to do this yourself, in the opinion of the scientists here?
Well,
It's
I
always
mean,
good to check your work.
yeah, anything in an
convert
astronomical program is going to be in declination and right ascension for sure already. But
what you have access to in the field is really only
Yeah.
your compass reading, azimuth, and and some sort of horizon feature. And then if you have an inclinometer, you can figure out how
Well, I
high
have
that feature is.
software that works in the field just on my phone, like Star Chart and the Stellarium. They're
I wouldn't-
available.
yeah,
I don't think I would
Stellarium
go
is a
there.
great
You-
program, but I wouldn't trust anything in the field on a cell phone. I mean, that's me. I know there's a lot of applications like Sunseeker and things like that, so that I use on the fly. But you certainly wouldn't put in a work that you're trying to publish. That I saw this on my Sunseeker app.
Well,
Right, but when you can take these your declination, you can take your azimuth and your altitude and all the measurements that you need, your GPS coordinates, and plug them in later to the software that makes these calculations. So that's what I'm asking is
Oh,
there a need
actually,
to do
that's-
these calculations on your
that's
own?
Yeah, I mean, one of the really important things that it's been instilled in me is once you have your declination and you've checked it against your ephemeris and your ephemerides, and you're gonna make a prediction about the celestial event, because it'll tell you that your best way to check your work is actually to get up in the morning before the sun comes up and go out and take and photograph it and get your photographic confirmation. And if you have that, I mean, that's really goes a lot further in the community, I think, than a planetarium software.
No, absolutely.
Right, of course.
I think
I'm just more addressing the point of this paper and the math involved.
Oh no,
in it.
I'm sorry. No, the point of this paper is, and if I'll just back up a little bit, I'll go to the very beginning. at the end of the paper, he talks about, that this talks about probability, but it doesn't speak to intentionality. But that really is the underlying question that everybody's trying to answer is, are these alignments that I'm seeing intentional? Were they intentionally built to look at this celestial event? And in many cases, we just can't know. I mean, there's, like in the case of northern Scotland, Ireland, and the monuments of the British Isles, there's no ethnographic data, there's no historic data. People that live there have been separated from the builders by millennia. So there needs to be another way of trying to get to that answer. And it's more about than intentionality, it's about meaning. What does it mean, really? And one way to do that is to see, is at least statistically, are these possibly intentional? And you can't get that from a planetarium software. Absolutely not.
Thank you. I'm sorry, I didn't read the paper, and
No,
if I
that's-
had, I would have understood that. Thanks.
No, but that's a very good question.
It's a great question. I just want to say I'm empirically trained, and error propagation is near and dear to me. So it doesn't matter what your instrument is. Whenever you take a measurement, there's always an error associated with it. So wherever that number comes from, you should be cognizant of what that error is, because then you take those numbers and you propagate it through whatever algorithm you're running. If you're assuming that your number is perfect, you're going to get a perfect answer. But the reality is there's some error to it. So if it's a planetarium software or a theodolite or whatever it is, there's always some error that should be propagated through your calculation to know that when you get your answer, it's your answer plus or minus something. And I think that's always important.
One last point though on the planetarium software. If depending on when you joined tonight, you might have heard some of the guys talking about 3D modeling and some of the stuff that they do. But lately, like George Zotti and others have been taking a lot of 3D models of archaeological sites with astronomical potential and creating 3D models and actually dropping them into Stellarium and then changing the date range to the appropriate time, appropriate era, and changing the horizon profiles from the stock profiles to the actual horizon. And if you have the 3D model, the horizon, and the correct time, you can certainly do a lot of error checking that way, or at least theory confirming. It's not really a phrase, but
So I would add, we had some success doing this at a technical workshop several years ago. We hosted at ASU, and some of the members here were there that time. And that was really our goal, was to kind of create 3D model, put it into a format where you could use it against software and sort of take readings. And I'm sure that's come a long way since we did that 3 or 4 years ago. We'll try another technical workshop soon. But the thing I noticed the most about that as we were going through that is the things you notice that you didn't expect. So yes, you go into one of these with a mindset of this is going to happen. But when you actually look at things over time, and when you actually are able to model and produce events, you see things that you didn't expect to see. You see things that you weren't looking for, and that's really meaningful. And so I think I think that the direction this is taking us is really perfect for our field, because it allows us to essentially create our environments. Then you can go back out and double check error and all that stuff to just really fine line it. But you get this really good sense of the potential of a site, other than just deciding you have an expectation and then going out and trying to find it. And so it's a good role of this kind of modeling, I would say.
Yeah, I would say that a lot of what one does in the field preliminarily, I mean, Chris is talking about using a compass and everything. You need to have, or rather it is useful. It saves time in the field if you do that kind of a preliminary analysis, that is frankly, at best, a fancy guesswork, and then go back into the field, if it's possible, to actually visualize what's going on. Or, where you can't do that, and where the this probability analysis is, I think, even more important, is on measurements of measurements of the possibility of a particular star at a particular epoch showing up to mark an event, because you get more than a few years away from current date and the sky has moved. Not so much at all for the sun, because it gets into geometry at this point. I won't go into all that, but the point is that you can go back 1,000 years with the sun and it hasn't changed that much. And it's usually, the errors there are usually less than other kinds of errors that creep up, especially in the Southwest, with erosion on a building, and maybe a corner is eroded away, or an edge of a rock that you want to say forms a shadow to fall on a given petroglyph. And the problems there are that you don't know what the place was actually like 1,000 years ago.
Right.
I'd say in the Southwest, especially, you don't need a lot of the, in many cases, not all, as I think Steve McCluskey's paper shows, but you don't need to have the probability analysis, because you can see anything having to do with the sun, you can see what's going on, and you're pretty close.
One thing I really liked about his analysis was this chart right here, which I found to be all over the place, really. And it didn't, it said, of course, that this was the equinox and this was the solstice, but they didn't really seem to stick out. I mean, obviously than this one, until he broke it out into different eras and different periods in the history of pharaonic Egypt into these four, which is really great. Now this one right here, I'm surprised, really surprised, that Fabio called this aligned to the equinox. And Belmonte only recently kind of readjusted that in a new book that came out in honor of Ruggles this year. Because this is kind of obvious, right? The pyramids and everything in the Old Kingdom was oriented towards the north. And if you're going to have a square that's oriented to the north, obviously one of your sides is going to point to the east. So these guys were pointed to the imperishable stars, basically Thuban, which was at the pole at the time, and the stars that surrounded it, because that was symbolic of where the pharaoh's soul was going to go when he died. So to label that as equinoctial is certainly not understanding the way that these people thought. And this one is really, this is a great graph from the Middle Kingdom that kind of holds over these two. There was still some of this going on, and this might have just been aligning to the other buildings that were already there. could be, because we started to get a lot of December solstice things here, and one of the things that they only briefly touched on in the paper, but I thought is a kind of an important note, that these temples were dual oriented.
Hello,
So the most important
can you hear me? Hi, Frederick. I'm watching a television program here.
most important
Yeah, good.
orientation was actually to the Nile. So these temples were oriented both to the Nile and to the winter solstice at the same time. And so that really kind of tells you the care that they took in choosing the location to build the temple, to have both of that duality. You know, the Egyptians called it Ma'at, and you know, so that they were aligned to the topography of the Nile, which was central to their cosmology, and to the rising sun and December solstice. And that's something that certainly came about a little bit in the Middle Kingdom and really took off in the New Kingdom. And I thought that was really cool, the way that this chart, you can't even see that, but when you start to break it up, it becomes evident using his new probability techniques. And then of course, this last orientation family is the same thing. It's just these temples were built oriented towards the Nile and perpendicular to the December solstice. And the last thing that I thought was really cool about the part about the recumbent stone circles, and I didn't put this chart in my slide deck, but you know, we've always heard that the recumbent stone circles of Scotland might be the only, you know, or the strongest argument made towards an orientation to lunar maximums, to the lunar standstills, because you know we have Chimney Rock, but that's an outlier, and you can't really do statistical analysis on an outlier. But we have all these, and the interesting chart, you know, that showed the orientation of the recumbent stone circles towards the lunar standstills and the solstice. It didn't really match convincingly at all using the new framework. So I thought that was important and interesting, if not a little disappointing. I don't know if anyone's got any other input on that one.
I really like the way he took his little chart of the recumbent circles and actually put it onto an image of the horizon.
Yeah.
And and that also sort of rang with me. It's a really good idea. It was a way to sort of match, or it's a way to take your data and visualize the error and the sigma on an actual horizon setting. And that was kind of cool to see. So that was clever.
Rick and I were talking earlier. It's difficult to visualize the statistics and probability. This would be perfect for a workshop where this was Rick's idea, where we could work through a problem and actually show how we get to those results.
Oh yeah, that would be great.
Yeah, so for some of you that might be new, one of the goals of the organization has always been to do an every other year conference, which is a reading of papers, but in the off years is to just kind of focus on some little technical things. And so we call them technical workshops. So we are proposing one for next year. And Chris, this, I hope you agree, but kind of just doing kind of a morning, maybe not a full day, but certainly a half day, just sort of getting people back into statistics. Most of us have not had a statistics class for 10, 20, 30, 40 years. And I have never used R, for example, and I know all the students now in my school use R. And I'd like to know a little bit more about that. I'd like to sort of, and then as Chris was saying, to just reinforce that, the ability to sort of sit and change data on the spot and say, so if we change the number, the N number, then this happens. And if we change this, this happens. And if we, I think that would be really, informative. I think a lot of people would enjoy that and just make the statistics a lot friendlier.
You might put in there the need for studying error propagation.
Yeah.
Another man spoke in favor of it.
Yeah, yep, absolutely. Chris can be the error champion,
Okay.
the kernel of error. Should we talk about that other paper?
You say, Chris, yeah, McCluskey's papers, predates this other paper by quite a bit, and it seems like, it is the predecessor for that, and I think he, applied it to some Safair's work, and I was trying to see what the conclusion really was. It seems like for summer solstice, it was good agreement, and less agreement for equinox and the winter solstice. That was what I took from it.
I think I almost saw the opposite. I thought that there was, I thought that what he was showing is that the summer wasn't statistically significant, I think, because I might have gotten it backwards.
Maybe I have it backwards. Sorry. So
No, I was thinking I did, but no.
There we
it was
go.
More, so do I have it right? So the summer solstice, what you're reading here is probability is, you want that to be a small number, not a big number. This is the simplest way to do that, I think. But I could be wrong.
I really didn't understand how he got his expected number of glyphs, because he assumed that there were 20 sites on the cylinder. And if he'd assumed that it was 10, these expected numbers would have dropped by 1/2. So I don't understand why there is a comparison between the two.
yeah, the methodology was very light, so I just took it for granted what everybody had done. But you're right. Did he maybe match the number of glyphs on the cylinder with the number of glyphs on the butte?
I thought that was an assumed number. Could be a misunderstanding.
And he doesn't say what the distribution of that number is. Are they just equally spaced around the cylinder, and is that how he's? I don't actually know either. So
Keep in mind that the slabs were a natural phenomenon and the glyphs were placed after the slabs were there.
yes. Well, in fact, I think he uses the dagger, the central part of the dagger, but in his calculations, he didn't use any of the outer rings, I guess. And maybe that was just to normalize the sort of the exact moment, I guess.
One question I had is just assuming glyphs on a cylinder doesn't take into account any complexity, like with the slabs and the, you can have a much more complicated geometry that has an effect. This is just purely
I thought it was just
statistical
exposure.
argument.
Yeah,
Right.
I think it was just exposure, potential exposure, I guess, right? And for a period of time, I guess. We should get
Yeah.
him on.
Yeah.
Somebody
Well, I've
call
always
him.
thought that's what's compelling about the Fajada Butte is the complexity of those slabs with the glyphs.
Well, true, but this kind of rebuttal, I guess is all you can call it, isn't so much about the famous sun dagger with the slabs. I mean, it does mention that, but I think only tangentially. It's talking about a collection of other petroglyphs that were published in a subsequent paper.
And he introduces that properly. So Sinclair and so far, yes, in a later iteration, they were sort of modeling that all of these glyphs, could have the same kind of attention to an astronomical phenomenon, and that's what he's kind of debunking here a little bit. And so it may be successful.
And I think this all relates to that quote from the first paper where you can't assume intentionality from probability. But it's a great test for, I guess it just adds to it, right? It's a piece of evidence.
I can't
Right.
wait to use that at a party.
Right. This is an interesting paper from another standpoint, because sometime after Steve published this paper, what you saw at the site was different. And that's because those stones that form or enable the so-called sun dagger moving, when they moved, they turned it into something that looked more like a rutabaga than a sun dagger. And that brings up another issue, which is this whole question of how much can you count on what you see today in a construction like even though it's a combination of a natural and man-made or woman-made structure, is that you don't really know what it looked like fully in say 1200 AD. And I think Bob Mark was the person who brought that to my attention.
Yeah, I was on the committee for the Park Service that tried to look at what happened up there after one of the slabs apparently moved. And the first thing you say is, this has been stable for 1,000 years and somehow it's moved within 2 years or 3 years of being discovered. But there were a lot of people messing around up there, and that could have had something to do with why it moved.
Right. Yeah, there were certainly some of the stones that were at the base of those large slabs were moved away, and maybe that caused more erosion in the area. Who knows?
Yeah, when we were reviewing everything we could find there, there's a contact sheet of photographs actually showing somebody lifting up and moving one of the rocks that was around the base.
Oh, no.
Oh.
Just a comment. Can you hear me?
Yep.
It brings up the ethical question of the researcher's effect on the research subject. And I think that was really ultimately a disaster because of that cause and effect to move those critical stones. I'm in Albuquerque, New Mexico. I put out a little book called The Petroglyph Calendar, an Archaeoastronomy Adventure in '97. And I never revealed the location. All my sketches remove some things that man has made that would make you know where it is. The sad part is it's right near a trail, and there's a lot of risk that someone on their bicycle will knock the orientation off the solstice alignments. But I think the point on the Vajada Butte is it's pretty sad what happened because of research.
I agree.
Thanks.
And I think that's, we're in an exciting time with all the technology we have where we can, make 3D models, put these in horizons and computers, and we can do a lot of work without having to repeatedly go to these sites and disturb them.
Excellent.
And that's something I'm
That's
near and dear to me, and that's something we're trying to do in the society as well.
Yeah, but we just do have to be careful, though, that our model doesn't replace, if you will, the original, and be careful about paying attention to errors that can creep in, whether it's because of weather or other factors, such as people walking over the site or moving stuff around a particularly critical orientation. So it's something that we just have to be as cognizant as possible about those kinds of issues, because I've certainly made a lot of mistakes by making assumptions about how things looked 1,000 years ago.
By the way, I put in the chat a link to a 3D model that we created just from the slides we had taken when we were working up there. So if anyone wants to take a look at it.
That's amazing.
Thanks. That's a great thing to have.
Yeah, that's a nice model.
When were the slides taken?
Oh, I'm guessing around 81.
Okay. Well, that's something I always find interesting with the models too. We can take slides from 81, models from today. You can really get a really good, accurate sense of how things have been moving and what's changed.
It's hard to put a reference for direction in here. I don't know if that's even possible.
Yeah, it's hard in the viewers. That's great.
I feel like I'm there.
So I think maybe I'll just summarize for myself to see if it makes sense. What I really liked about both these papers was it's a completely different approach and another data point to measure, just to give statistical significance based on kind of like the null hypothesis of, the randomness of, is this a random event or not a random event? And I think that is kind of the theme that's come up out of this journal club, is if you go out there looking for a solstice alignment and that's all you're looking for, that's all you're going to see. And this gives you the tool to take that alignment that you've seen and then ask the question, what is the odds that this happened randomly? That's kind of what I took from the work.
Yeah, I absolutely agree. I think you really need to, and this just isn't done often enough, you really need to question what you think you're seeing or measuring or any of the above, and test it in various ways to see if it makes sense after you walk away from it a bit.
I'd love to get the author. Maybe we could, Rick, get him. He'd be perfect for the workshop, because I'd like to.
Yeah.
I understood the concept, but I don't know if I could execute on this.
Yeah, no, I wouldn't be qualified to do it either. No, we'd have to have somebody, either somebody just, kind of from statistics, but better somebody from, kind of from the field. So he would be good, or maybe he knows people that would be good. But that would be a worthy idea to try to get him to just walk us through a half-day workshop. I would have to go back a couple steps. I mean, this was really dense for me and very, very difficult to sort of follow. Just, just because I don't know statistics as this well by any means. I just know the general ideas.
And one more comment on your question, Angeline. I'm a big believer in the best instrument that you have in the field, whatever you have on you. So whatever tools you have, the measurements are fine. It's really about knowing what the limits are and then, measuring the error. Because then you can take any measurement as long as you understand the error, and then you can know the significance and to do further research and know whether you need to go back.
Good point.
I was very impressed with the comment on the difference between intentionality and statistical significance. If you can imagine standing on a bedrock outcrop with a high point and maybe a boulder to its right, if you look from the high point to a distant marker and it lines up with the solstice, and it's significant, you still don't have the evidence that it's intentional. It might be better to go over to that boulder that's nearby and use that, if you inspect it, and see if it has a human modification. Then you would have some evidence of intentionality of a viewer.
I think, don't you need to look for sort of a constellation of, coincidental factors generally to come up with that, to determine intentionality at a rock art site, for example? You've got the sun alignment that looks pretty good, but then if there's no pictographs nearby or, anything else that would coincide with that, it could be accidental. But once you get a few different factors lining up, you can start to interpret intentionality, in my opinion, or in my experience rather.
Aubrey Burrell has a criterion that you have to have an indication of a place to stand and an indication, a sight line on an astronomically significant item. And if you have that and it reoccurs in some other site, it's pretty good evidence that you've got one. So you have to have the intentional indication of a place to stand.
And of course, the best evidence is if the cultures left a written record that said, hey, this is what we were doing. So you have that with Egypt, you have it with China. You don't have it, in ancient Scotland, where we were reading about the recumbent stone circles. You don't have it in Polynesia, but you do have an ethnographic record that you can rely on, and you can make some inferences about the past based upon some practices of, descended cultures. But if you don't have any of those kind of converging chains of evidence that you can look at, you're really left, with nothing. And then in those cases, statistical analysis can help, help you make your case. A lot of times you'll just never ever be able to prove intentionality, but that's not really the point. It's making the best case you can, and then determining, or trying not to determine, but trying to interpret what was the meaning behind that, and how can those findings shed light on the cosmology of the people? Because without that, we're just talking about angles.
Well said.
Yeah, that's excellent.
I've got to go feed the cat, so I'll say good night.
Yeah, I'm gonna have to actually go myself.
All right.
Thank you, Chris and
Yes.
Chris.
Yes, thanks very much.
Thank you all.
And
Thank you.
I'll go back and reread the statistical analysis again, see if I can make better sense out of it than I did.
Your wisdom is appreciated.
Yeah, it's a tough one, but I want to make sure that I'm learning just as much as you know, and this is a paper I was aware of for a long time. And I needed to force myself to sit down and slog my way through it, really. And this was,
Well, we thank you.
well, thank you.
Yeah, these are great. These are tools that I think will be very useful, and I'm hoping, I'm sure they're going to mature, so we'll see more and more, maybe a little more accessible, turn into actual tools we can use. But
Well, actually, Fabio does have a program, Skyscaper,
okay.
that I'm not sure the state of it. I'll have to ask him, but
Well, it's sounding more and more like he needs to be in our workshop. And I'll just remind everybody.
I didn't get to read the papers, but I am a statistician, so I'll go back and do some homework. I'm a biostatistician, but that's what attracted me to tonight's topic. So I really want to thank you.
Perfect. And I'll just remind everybody, I did get the schedule up through April on the website. So we'll have, and I'll send that out in the next announcement. So we have the papers and the dates, and we're in the process of getting the actual copies of the papers, but I have the titles and authors and all that. So slowly but surely getting a little more organized.
Great. Thank you very much, both of you.
Does
Good night,
anybody
everybody.
here? Does anybody here work on Native American topics in the human-speaking territory?
I grew up in Yuma, Arizona, and that's right in my area. So I'm in the process of learning a lot, but I'm not anywhere near an expert, but I have a strong interest.
But do you kind of, have you dived into the cultures and the symbols and the lifeways and those things, so the anthropology of the human speakers and who maybe came before?
No, not. I'm like just starting getting more.
Okay.
I started in the Hohokam and I've worked my way back into. I'm really looking at the geoglyphs along the Colorado River right now. So I'm doing a deep dive on the kind of I need to do my background reading. That's where I'm at.
Would you mind putting your email address in the chat, because I actually have some Hohokam questions as well.
Okay.
If you have any Pawnee or D-Day questions, we have one of the world experts on our call with us tonight.
Oh, who's
Well, Dr.
Rondell,
who? Which one? Who?
Rondell Chamberlain.
Yes, I saw that. I'm very impressed. I read his books.
I'm so excited to be amongst such a distinguished crowd. Thank you for allowing me to participate.
We're delighted.
Okay. I just put my email in, and I'm the one sending out the announcements, so you can always reply to that.
Okay, great. I was at the original Oxford conference there in Flagstaff and all, and the one prior to it in Oxford, I think it was. So that's where you got my email address all way back in the day. Thank you so much, Hubert Allen here.
Your email
Perfect. Yeah,
didn't-
I just
it
sent
didn't
out to
come
every
through.
email we had. So
Wonderful job. You got me. And I think I'm going to join. I haven't yet, but I think you'll get some dues from me. I got to go. Thank you. Bye.
perfect. Thank you so much.
Hit send. Oh, there it is. Okay, president. Okay, that's easy.
Yeah,
Thank you.
Yeah.
Thank you so much.
Perfect.
Thank you. Happy Thanksgiving, everybody.
Likewise, everybody.
Yes.
Bye.
That's
Happy Thanksgiving.
I'll see you guys soon.
Right.
Yep.